Okay, so on this one, we have a function and it's a pretty complex function, and they want us to handle it by logarithmic differentiation. That's because it's got x's in the base and in the power. We don't really have a rule for how you take the derivative of something with x's in the base and in the power. We have a rule with x's in the base only, like x to the fourth. We know the derivative is 4x to the third, or x's in the power only. I don't know if you know that one. That's like e to the x. So you just go 10 to the x, but then you have the adjustment, ln 10, But we don't have a rule where x's are in the base and the power, so we have to use logarithmic differentiation. Step one of that is you take the ln of both sides. So I'm going to go ln of the left side, ln of the right side. Two things are equal. You take the ln of both of them, they're going to be equal afterwards. So there we go. Step two, you use the log properties. Now there's from pre-calculus, there's three log properties. Number one, the log of x times y is the log of x plus the log of y. Property two, log of x divided by y is the log of x minus the log of y. And property three, the log of x to a power. That power can come down to the front, be power times log of x. So I'm going to use it now. The left side, there's no properties going on the left side. It's just ln of y. But on the right side, I'm going to take this power and bring it down. It's going to be x times ln of 4 plus cosine x. Now you might think, okay, yeah, I know the next step. Let's just make that ln of 4 and ln of cosine x. No, 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 no. That we can't do that. It's illegal. That's really not one of the properties. But I say, yeah, it is right here. No, look careful at that. That's times. So if you have inside the log, if you have two things multiplied, that can become two separate logs added. But we don't have two things. This isn't, if this was 4 times cosine of x inside the ln, then yes, I would make it an ln 4 plus an ln, ln cosine x. But it's not times, it's plus. You think, well, just distribute. No, this is not multiplication. These properties have never, ever been multiplication. That was not what was going on in pre-calc. This is not times. You think, how do you know? It looks like times. Well, no, no. This is a function. Natural log, any log, sine, cosine, tangent, e to the x, those are all functions, which means whatever comes in the parentheses after them is not multiplied, it's plugged into them. So anyway, can't distribute. This is not multiplication. And if this was times, then we could do property one, but it's not. So we're done with the properties right there. Now what? Step three says take the derivative of both sides. Take the derivative of both sides. So I'm going to go, okay, derivative of both sides. So I'm going to take the derivative of this side, the derivative of that side. Okay, now how do you take the derivative of that left side? Well, excuse me. You've probably seen it a couple times now. When you'd have ln of y, the derivative, what is it? Well, we know that the derivative is 1 over the argument times, and then the inside is not a simple y, so we got to do the chain rule. Chain rule says you got to multiply by the derivative of the argument, which would be y prime. So simplifying that, the y prime over y goes to the top, so it's y prime over y is how we like to say it. Sorry, that's a little scribbly. Let me just put it right here equals y prime over y. Makes sense? When we have the log of something, the derivative is 1 over that thing times the derivative of the inside, because the chain rule says if it's not a simple x, going to multiply the derivative of it. That's over 1, goes to the top. So it's y prime over y. So the left side, so that's pretty much what happens every time. Call it f of x, call it y, whatever. It's y prime over y equal. Now, how am I going to take the derivative of the right side? Well, if you look at it carefully, you'll see it's two functions of x multiplied. So that's going to be the product rule. isn't it? Right? Two things multiplied. So they take turns. Derivative of the first two functions of x multiplied. Derivative of x is 1 times the second function unchanged. Ln of 4 plus cosine x. Um, Plus, and then the first function unchanged times derivative of the second function. I'm just going to simply run out of room here. All right. Let me drop it down. Sorry, I'm just going to run out of room. I just don't got room. So let's take derivative of that function. What's it going to be? It's going to be y prime over y. The right side, okay, one more time, it's product rule. Two functions multiplied. So the first one goes first. The derivative of x is 1 times the second function unchanged. It's not his turn right now. Plus the first function unchanged times the derivative here, derivative of the second derivative of this. How do you take derivative of that? Well, we know you multiply when you have logs, you always go 1 over the argument. But chain rule says if the argument, what's inside, is not a simple x, you're going to multiply by the derivative of the inside. That part 0, derivative of cosine is negative sine, derivative of the inside. All right. So let's clean that up a bit. Yeah, good there. Did I lose you on the last part? Maybe I better recap one more time. Derivative of natural log of anything is 1 over the argument. And if the argument's not a simple x, you're going to multiply by the derivative of the inside. And the derivative of the inside is just derivative of cosine is negative sine. Derivative of 4 is just 0. It's gone. There we go. All right, let's keep it cleaning up here. Equal to, so this is just going to be ln of 4 plus cosine x plus, now this x is over 1, goes to the top. So these guys are both going to the top. And one of them is going to be negative. So I'm just going to say, look, it's going to end up minus, and then you got a bar. On the top will be x sine x on the bottom for plus cosine x. You see what happened there? On the top, this x multiplied to 1, this negative sine x. So it's negative x sine x. So I just put the negative in the front, x sine x over the denominator. All right, we're not, you might think, was that the answer? Not almost. Y prime's not alone. We gotta finish getting y prime. They want dy dx, which is y prime alone. How do you do that? Are we done yet? What's the last step? Are we there yet, Dad? All right. Step 4. What we always do is we multiply both sides by y because we got to get y prime alone. So I'm going to multiply by y over 1, so these will cancel, and the whole right side by y. So y prime is finally alone. Here we go. It's y. Now what's y? Y is the whole original function, that whole thing. 4 plus cosine x to the x. So 4 plus cosine x to the x. And then everything else, which is going to be natural. Write it all out here. 4 plus cosine x, right? Minus. And then x sine x over 4 cosine x. Woo! There it is, because all of this is that y. You realize, right? That's why that all came down. All of this is y, and then there's all of that. That's the derivative. That's not easy. Did we get that thing right? It just looks almost impossible. But it was a lot of steps, wasn't it? A lot of steps involved in that. There we go. It won't let me. Let's see, did we get that right? Ln. And we had it right on the left, and And then minus x sine x. Yeah, we get it. That's it. There it is. That's a tough one. There we go.